Hi, I'm Aleksandr. I'm presenting my master thesis PolarMOT with Guillem, Aljosa, and Professor Leal-Taixé. 3D multi-object tracking is a task defined on a tracking sequence where as input you receive 3D binding block detections and as output produce temporally linked object instances. PolarMOT represents this tracking sequence as a temporal graph where object detections are represented via nodes and edges are pairwise relationships between these detected objects. Unlike previous work that focuses on tracking as a task of identifying consistency over time, we focus on object evolution over time. As such, we initialize only our edge features and let the model implicitly learn node features through a simple neural message passing algorithm that does alternating edge and node updates. At the end, a binary edge classification problem is posed as the tracking task. Our main contributions are sparse multiplex graph structure, localized polar representation of edge features, and a technique to bring our method to online streaming scenarios. To accurately capture the full context of a tracking sequence, we define two types of edges. One to represent object motion over time, and second to define influences between objects in the same frame. As such, we identify interframe temporal edges in blue and interframe spatial edges in red in our input graph. For our edge features, instead of representing differences in poses in global Cartesian coordinates as a standard in previous work, we propose to use localized features based on polar coordinates, which provides us with a few advantages, namely invariance to global transforms such as smooth turns, a better non-holonomic motion prior, more suitable for tracking tasks, and it ensures that identical motion results in identical features as shown in the graphic here. And lastly, we show how to bring our method to online streaming scenarios by defining our input graph that evolves over time to maintain sparsity and retain a global receptive field, temporal receptive field. We set a new state-of-the-art on the nuisance dataset among 3D only methods, and we show importance of all our contributions through ablation studies when we compare our method with and without interframe connections, when using standard Cartesian coordinates or ignoring time invariance, and compare our online graph technique with possible alternatives. We also present two generalization studies where, without retraining, our model can generalize from new scenes to the Kitty dataset and between two different cities, Boston and Singapore, which is the strength of our focus on object interaction instead of appearance or other object information. Please check out our website for more information. Thank you.